Let's now work out the mathematical formula that will allow us to figure out the amount by which a moving object is shortened in its direction of motion if we know what its speed is. And what's the essential idea there? Well, we're going to just do a little bit of algebra, simply making use of Gracie's approach for measuring the length of the train, and we'll compare that to a similar calculation that George could do. And we'll see that George's answer will always be different from Gracie's. Gracie's answer is going to be shorter than George's if she's watching him rush by. OK, so again, what's Gracie's approach? She simply says that the length of the train is equal to the product of the speed of the train times the amount of time, according to her, I'll call this now T. Gracie, the amount of time on her watch between when the front of the train passes her to when the end, the back of the train passes her. Good. OK, now bear in mind that George could actually play the same game. We described him measuring the length of the train using a tape measure. But look, George could, on the train, as he's going along, he could look at Gracie. He could start his watch when he passes her. He could stop his watch when she passes the back of his train. And in that way, he could get a length, which would be the length of the train from his perspective, which would be v times the amount of time that elapsed on his clock. Good. Now we can compare these two because we know that the amount of time on Gracie's clock is going to be shorter than the amount of time on George's clock, right? Because we know that a clock that's in motion, and again, from George's perspective, Gracie's clock is in motion, so that means that this gamma, which is bigger than 1, goes downstairs. So the amount of elapsed time on Gracie's clock is less than the amount of time on George's clock. And therefore, we can now plug that back in upstairs. So gamma downstairs means we have T times George times, this is 1 over the square root of 1 minus v over c squared. So putting it downstairs brings upstairs a factor of 1 minus v over c squared. And now we are done, because if we plug that into this equation over here, we have v times T Gracie, I'm now going to write as T George, times square root of 1 minus v over c squared. And now I look over at this expression here, and I recognize that the piece of this in brackets, v times T George, is just the length of the train from George's perspective, which means that the quantity that I have on the right-hand side here, this can be rewritten as the length of the train according to George, in the brackets, times the square root of 1 minus v over c squared. So then, putting it all together, we now learn that the length of the train, according to Gracie, is equal to the length of the train according to George times this factor of 1 over gamma, which is 1 minus v over c squared. And again, this quantity over here, this is 1 over gamma. This is always less than 1, which means the length of the train according to Gracie is always less than the length of the train according to George. So basically, you can see it right here. This all comes from the time difference between their two measurements of how long it takes the full length of the train to pass one location in space. And basically, space is compensating for that time difference in just the right way, actually, to keep the speed of light constant. But the bottom line is, the length of the train, according to Gracie, she's watching it rush by, will be the length of the train, according to George, times this factor that is less than 1. So now we can go back to this demonstration of these ideas with a little additional understanding now, because we have an understanding of where the amount of contraction comes from mathematically. So in this expression, we now have gamma shown as well. We didn't have that before. So you should play around with this to get a feel for it. And there you see it. As gamma gets bigger, then 1 over gamma gets smaller and smaller, and that's the amount by which this is contracting. And that is the mathematical version of the idea that we described earlier qualitatively. That's the quantitative way to work out the degree to which an object rushing by will be shortened along the direction of motion.